Hello everyone, welcome to online video lecture series developed by Jawaharlal Nehru Technological University Kakinada in association with Andhra Pradesh State Council of Higher Education. This is Dr. M. Prem Kumar, working as professor in the Department of Electronics and Communication Engineering, Sri Vishnu Engineering College Foreman, Bhimavaram. Welcome to video lecture series. In this lecture number 1, we will discuss about introduction to linear systems. Before getting to the linear system, let me define what is a signal. A signal is defined as a physical quantity that varies with respect to time or space or any other independent variable or variables. Normally, it is represented with x of t, where t is an independent variable and x is a dependent variable. If you observe here, x is a dependent variable and t is an independent variable. And this is an example for 1D signal, one dimensional signal. Examples are, as I am speaking now, my voice signal is a best example for 1D signal. With respect to time, my signal amplitude levels are varying. And another type of a signal is a 2D signal, dimensional signal. The best example for two-dimensional signals are image. So this will be represented in terms of f of x comma y, where x and y are the spatial coordinates and f is the intensity value at x and y. And this can be treated as a two-dimensional signal. So best example for a three-dimensional signal. This is represented v of x comma y comma t. An example for this will be a video signal. So number of frames per second with respect to time, the frames are moving, so that is nothing but a video. And let me define what is a system. A system is defined as a physical device that generates a response or output signal for any given input. You apply any input to a system, it will generate some output y of t. Input is x of t. So relation between the input and output is y of t is nothing but the transformation of x of t. So that's why this is represented. Where x of t is input or excitation and y of t is output or response of the system. This transformation may be anything. Whenever we apply any signal x of t, output is nothing but some modification to the input signal. That means input signal will be processed to get the output y of t, which is nothing but some transformation of x of t. Now coming to the linear system. A system that obeys the superposition principle is said to be a linear system. What is a superposition theorem? The superposition principle states that the response to a weighted sum of input signals be equal to the corresponding weighted sum of outputs of the system to each of the individual input signals. Now, whenever you apply input x1 of t as input to system, you will get the corresponding output is y1 of t, which is nothing but the transformation of x1 of t. Now, whenever you apply another input x2 of t as another input, the corresponding output is y2 of t, which is nothing but the transformation of x2 of t. Now, you apply the combined signal a into x1 of t plus b into x2 of t, then it should give a into y1 of t plus b into y2 of t. A system which satisfies this condition is called a linear system. A system does not obey superposition theorem comes under nonlinear system. Then whenever you apply x1 of t as input, output is y1 of t, which is nothing but the transformation of x1 of t. Then apply another input x2 of t, which is nothing but output is y2 of t, which is nothing but the transformation of x2 of t. Similarly, you apply the combined signal a into x1 of t plus b into x2 of t, and you will get a into y1 of t plus b into y2 of t. Then it's a linear system. If it is this condition is not satisfied, then it's a nonlinear system. So here a and b are arbitrary constants. Now let me solve one example for better understanding of linearity and non-linearity of the system. And let me take an equation for input-output relation of a system. Y of t is equal to e power x of t. X of t is input and y of t is nothing but output. Relation between output and input is nothing but transformation. Here exponential is the transformation. Now what we have to do is we have to apply x1 of t as one input. The corresponding output is y1 of t, which is nothing but e power x1 of t. Then apply another input x2 of t. Then you will get y2 of t, which is nothing but e power x2 of t. Now you apply another input x3 of t, then this will be equal to y3 of t, which is nothing but e power x3 of t. Now the condition for the linearity is, so x3 of t, just I am replacing this with a into x1 of t plus b into x2 of t. Then whenever you apply this signal, what you will get is this should give y3 of t, which will be equal to e power x3 of t. Now what is x3 of t, which is nothing but e power a into x1 of t plus b into x2 of t. If we simplify this, what you will get is e power a into x1 of t into e power b into x2 of t. But you should get transformation of y3 of t. You should get a into y1 of t plus b into y2 of t. So what you get is a into e power x1 of t plus b into e power x2 of t. But what you got is e power a into x1 of t into e power b into x2 of t. If you observe in the previous thing, and these two are not equal. This and this is not equal. So this is a linear or non-linear? This is a non-linear system. Straight away we can say that once it is a exponential function, we can straight away say that it's a non-linear system. So, and let me take another example. Y of t is equal to t into x of t, and this is the given input-output relation of a system. You apply x1 of t as input, what you will get is y1 of t, which is nothing but t into x1 of t. Apply another input x2 of t, which is nothing but y2 of t, which is nothing but t into x2 of t. Then what you have to do is you apply x3 of t, then you should get y3 of t, and this should be equal to t into x3 of t. Then what is x3 of t? Which is nothing but a into x1 of t plus b into x2 of t. Now this should be given as input. Now the corresponding output is y3 of t. What is y3 of t? T into x3 of t. So which is nothing but t into what is x3? A into x1 of t plus b into x2 of t. Then this will be equal to a t into x1 of t plus b t into x2 of t. And this is nothing but a into what is this t into x1 of t is replaced with y1 of t. Similarly, t into x2 of t replaced with then y2 of t. So a into x1 of t plus b into x2 of t is equal to a into y1 of t plus b into y2 of t. So the given system is linear system. And let me take another example in terms of discrete time system. Y of n is equal to n square into x of n, where x of n is input and y of n is output. So here n is an independent variable. Procedure is same. You have to apply x1 of n to get y1 of n, which is nothing but n square into x1 of n and x2 of n, you will get y2 of n, which is nothing but n square into x2 of n. Then you apply x3 of n, then you should get y3 of n, which is nothing but n square into x3 of n. Now what is x3 here? x3 of n should be equal to a into x1 of n plus b into x2 of n, and this should give and y3 of n, and which will be equal to n square into x3 of n. What is this n square and what is x3 of n? This is a into x1 of n plus b into x2 of n bracket. Now this will be equal to a into n square x1 of n plus b into n square x2 of n. Now this can be written as a into y1 of n plus b into y2 of n. So on the left hand side, what is this? A into x1 of n and plus b into x2 of n is given. So the given system is linear system. Now let me take another example. Y of n is equal to 2 into x of n plus 1 by x of n minus 1. Once you know the input output relation, you have to apply x1 of n. Procedure is same. Then what you will get is y1 of n, and this is nothing but 2 into x1 of n plus 1 by x1 of n minus 1. Similarly, x2 of n, you apply, the output is y2 of n, and this will be equal to 2 into x2 of n plus 1 by x2 of n minus 1. Now what we have to apply is x3 of n, and should be given y3 of n, and this will be equal to 2 into x3 of n plus 1 by x3 of n minus 1. Now what you will get is, so y3 of n should be equal to x3 of n, 2 into x3 of n plus 1 by x3 of n minus 1. Now what is x3 here? x3 of n is nothing but a into x1 of n plus b into x2 of n. When you apply this in terms of y3 of n, this is nothing but 2 into, in place of x3 you have to substitute a into x1 of n plus b into x2 of n. This is in place of x3 plus 1 by, what is x3 now? A into x1 of n minus 1 plus b into x2 of n minus 1. Okay, now what you have to get? A into y3 should be equal to a into y1 of n plus b into y2 of n. What is y1 of n? This is a and this is 2 into x1 of n plus 1 by x1 of n minus 1. This is y1. Similarly, b. This is b into 2 into x2 of n plus 1 by x2 of n minus 1. Now, if you observe this and this term 2 into a of x of n minus 1, this and this is okay. Now, and this term is okay. Now, what about this one? This whole thing and this term and this term is not equal. So, the given system is non-linear system.